So one of the last things that was said in a previous lesson was eventually we're going to have to undo the chain rule. Well, it's eventually. It was the very next lesson. So if I take the derivative of a composite function, I would use the chain rule, and this is what I get. So because this is true, comma, the integral of the chain rule means that I will undo the chain rule, and it looks ridiculous in this process, but I want you to hang with me for a second. So if you're looking at this box and you're like, I have no idea what's going on, hang with me, okay? First, we're going to find the derivative of f of x if it's cosine of 4x squared. And I'm going to go like old school, and we're going to list the f's and the g's using the formulas that we know. So the biggest thing happening, and I say f not meaning f, I mean the biggest thing happening is cosine of u. F prime would be negative sine of u, and then g would be the inner function. We've been through this quite a bit. G prime would be 8x. And then in the process of finding the chain rule, the derivative, we would use the chain rule. That is going to go in right there. So we'll have negative sine of 4x squared times 8x. We'll put it right there. Okay? So the derivative of this f, not to be confused with these f's that are placeholders in a formula, the derivative of this is that. So if you wanted to call this, and I'm going to cheat a little bit, you don't have to do this, but if you wanted to call this y, then this would be y prime, okay? So now I'm asking, what is the antiderivative of negative 8x? I was looking here first. Antiderivative of negative 8x sine of 4x squared. I would simply be moving backwards to this. So I want you to notice what's happening. In the process of taking the derivative of the inner piece, 8x, pops up. In the process of taking an integral, it would go away. All right? So I hope you noticed that this 4x squared just sort of stays there. And the derivative of 4x squared is 8x. Now I know there's a negative. Let's ignore the negative. Derivative of 4x squared is 8x. And if I was working backwards, it would go away. So let's force it to go away. The best way I know to explain it is with a black pen. There's going to be a lot of highlighting in this. So here goes. First time we ever do this, what I recommend you do is identify the innermost function, which in this case would be 4x squared. Now let's be honest. We know the answer is this. We're aiming for that. What is the derivative of this with respect to x? That would be 8x, okay? Now, because of the way the notation works and the fact that it looks like a fraction, we can go one step further and call it 8x dx. All right, here's what's about to happen. I'm going to grab some highlighters that I should have had with me. And I'm back. And we are going to build this here. It is the integral. The integral of what? A lot of stuff. Okay? Integral of a lot of stuff. There's a lot of stuff going on right here. We are integrating, the biggest thing happening, somebody's getting signed. So we're going to say, oh, there's a sign right here. Okay? So I personally like to highlight corresponding parts. Sine. Okay? Now, in just a minute, I'm going to add a little bit to that with my orange highlighter. If you're not highlighting, it's totally okay. So what are we signing? We are signing 4x squared. I don't want x's over here. I'm transitioning from x's to u's. So instead of 4x squared, I'm just going to put u. 4x squared is u. So instead of 4x squared, I'm going to put u. I finish when everything over here highlighted matches with everything over here highlighted and nothing's left unaccounted for. Okay? And again, what's happening is I'm changing everything here from x's to here with u's. Okay, well, what else are we dealing with? Well, let's see. 8x dx is du. Okay, all this work is going to help us build things over here. So 8x dx is du. 8x dx, let's get a different color. 8x, not negative 8x, but 8x dx is du. Colorful lesson, isn't it? 8x dx is du. The only thing that we haven't dealt with is this negative. I don't need another color. So instead of saying the biggest thing happening is sine, I could say the biggest thing happening is negative sine. Now all this is multiplied. Well, this is an operation. This is negative 8 times x times sine of 4x dx. And this dx is an operation that looks like and acts like multiplication. So this negative is also orange. Okay, so just to recap, get it? Just to recap, biggest thing happening is that somebody got negative signed. Good. Who got negative signed? 4x squared. Well, who really got negative signed? You did. U is 4x squared. Okay, well, what's left over? 8x dx. That's du. Okay? At this point, we're simply going to integrate this using old school technology, not technology, but old processes that we already know. The integral of negative sine would be, okay, the derivative of something gives me negative sine. It must be cosine, and then plus c. This pen's about to go. Still using the same pen. And so I'm almost finished. Now, are you going to highlight? No. This just accounts for everything here. And so we move forward. And so I have cosine of u plus c. Well, I don't want my final answer to have u's in it anymore. The u substitution that we're using is a way to account for every little thing in the process. And so final answer might be the last thing I write with this ink pen. Cosine of u, which is 4x squared, and then plus, make it a good one, about to toss a pen, c. It might have a little life left in it, I don't know. Okay, that's your first example. They're going to get a little bit crazier. If you're worried about all the stuff in the box and what does it all mean, and do not panic, do not panic, do not panic. Big idea is this. The inner function, the derivative of the inner function, that g prime, would go away in the process. Just like that 8x vanishes and it works its way out. So 8x going backwards, give me that. There you go. See? Same thing, not a coincidence.